Let us look into the sixth question. Design Verilog program to implement different types of multiplexers like 2:1, 4:1 and 8:1. A multiplexer has a group of data inputs and a group of control inputs. The control inputs are used to select one of the data inputs and connect it to the output terminal. We have 2:1 multiplexer where we will have two data inputs and one select inputs. 4:1 will have four data inputs and two select inputs. 8:1 will have eight data inputs and three select inputs, and so long up to 2 to the power n is to 1, where we will have 2 to the power 1, 2 to the power n data inputs and n select inputs. Note that all multiplexers will have a single output. When we look into the code of 2:1 multiplexer, we will have two inputs, 0:0s and input 1:0d, and output will be y. We will have two cases in 2:1 multiplexers. These are the two cases, and finally end case and end module. In 4:1 multiplexer, we will have two input and one output, and we will have four cases where d of 0 is the output, d of 1 and d of 2 and d of 3, end case and end module. In 8:1 we will have 1 2 3 4 5 6 7 8 cases, and we'll have two inputs and one outputs, and we will have three select inputs as well. In 4:1 we will have two select inputs, and in 2:1 we'll have one select input. The output of 2:1, 4:1 and 8:1 is as follows. In 2:1 multiplexer, we will have 1 and 0, 1. In select inputs, we will give 1 as select input, and our input will be 0 and 0. So the output will be 0, where 1 will allow 0 to flow into the output. In 4:1 multiplexer, we will have two select inputs, and the select inputs will be 1 and 1. The data inputs will be 1, 0, 1, 1, 0, 0, and 1, 1 will allow 1 to flow into the output. In 8:1, there will be 8 inputs, 8 data inputs and 3 control inputs. In control inputs, we'll give 1, 1, 1 as control, and in the data inputs, we'll give 0, 1, 1, 0, 1, 0, 1, 0, and the 1, 1, 1 will allow this 0 to flow into the output, and we'll get the output as 0 at the end.